Hi there, welcome to Cryogenic. In our geometry video series, in this video we are going to cover all the must-know basic and advanced concepts, formulas and theorems related to circle. And I'm sure after watching this video, all the secant theorems, all the chords problems, all the tangent theorems and various angles properties will be very much clear to you, and you will be able to solve each and every questions in a much easier way, much comfortable way. So let's start the video. Concept 1: radius, diameter, chord, secant, tangent and passant. So what is radius? So radius is a line segment joining the center of circle with any single point on the circle itself. So here in the diagram we can see that point O is the center of the circle, and then we have drawn a line from center O to point K, and that line is a radius of the circle. So we can take any line segment that joins the circle, basically the joins center of the circle to any outside point at the circumference. That line is a radius of the circle. So in the diagram here, line OK is a radius. Next is diameter. What is diameter? So diameter is a line segment whose endpoints lie on the circle and that passes through the center. So in the layman term, we can easily understand that line which is just touching two outside point of the circumference and passing through the center, that line is a diameter. And remember that diameter is double the radius, right? Because half the radius is at 1.1 center, like a point, like center to the outside point, center to the circumference. That line is a radius. If we'll take both the side, that line is a diameter. So diameter is double the radius. And again, key important thing is what? This is the largest distance between any 2 points on the circle. So here in the diagram we can see a line segment AB passes through that point O, which is the center of the circle, and that line segment AB is a diameter of the circle. So line AB is passing through the center O, so and then in that case line AB is a diameter of the circle. And again, key things about the diameter is what? Diameter is the double the length of radius, and diameter is the largest distance between any 2 points on the circle. Next is chord. What is chord? Chord is the line segment joining any 2 points on the circumference on the circle. So obviously, like any 2 points, if you take circumference on the circle, so that line is a chord. So definitely one chord will pass through the center. So obviously that chord will be a diameter. So diameter is a chord which passes through the center of the circle. So here in the diagram we can see a line segment RS joining 2 points on the circumference of the circle. So line RS is the chord of the circle. And we can take any line segment and that joins any 2 points on the circle. That line will be a chord. Again, remember, key important point is what? The chord, the largest chord of the circle is a diameter. So obviously the largest chord will be diameter only. Next is secant. What is secant? A line that intersects a circle at 2 points and extend outside the circle. So when a line which is joining any 2 point on circumference of the circle, but we are extending outside the circle also. So when I'm extending outside the circle, so that line is a secant. So in the simple word we can say when we are extending chord both the side outside the circle, that chord is a secant, right? So here, like if we can extend, you can see in the diagram, if we can extend any chord outside the circle, and that is a secant. In the diagram we can see the line EF is the secant of the circle. Next is tangent. What is tangent? Basically a line that touches a circle at exactly 1 point and perpendicular to the radius. So like if you draw any line and that line just touches the circle, and the line that is just touching the circle, that line is a tangent, and that will touch only and only at 1 point on the circumference of the circle. And when it is touching on the 1 point, and that point, like that line and the radius the angle at that point they will form, that will be 90 degree. That angle is a 90 degree. So that is a tangent. So we can say that line that touches the circle at exactly one point and perpendicular to the radius, that line is a tangent. Next is passant. What is passant? A coplanar straight line that has no point in common with the circle. So a line which is outside the circle, it is nowhere, like neither it is touching the circle nor it is entering in that circle. So it is just outside the any point, any line which is outside the circle, that line is a passant. So here we can see the line TW which does not touch the circle, that line is known as passant of the circle. We know what is area of circle. It's very simple concept. Area is what? Pi r square and circumference is 2 pi r. So what is area? Area is basically usually mean the area of region enclosed by the circle. The area enclosed by circle of radius r is what? Pi r square. So we know area is equal to pi r square. So what is area? Area is usually meaning the area region enclosed by the circle. And what is circumference? Circumference is the length of one circle uh, along the circle, or the distance around the circle. So outer boundary, or simple word we can say the outer boundary of the circle is a circumference. So area of circle is pi r square and circumference of circle is what? 2 pi r. Important thing is what is the relation between the area and circumference of uh, circle. So we know the area is what? Pi r square and circumference is 2 pi r. So r is common, so we can easily derive the relationship. So we can say area is equals to half of circumference into radius. So concept number 3, arc, sector, segment and sagittars. So what is an arc? An arc is any smooth curve joining 2 points. As we can see in the diagram, that red part is a smooth curve joining two parts. That point PQ is an arc of the circle. So obviously, like when we have one arc and when we draw a line like from both the points of the arc to the center, so that part is known as sector. So we have now, when we can say we have two part of the circle. One is what? The major arc, and another is what? Minor arc. So 2 points lying on the circle actually define two arcs. The shortest is called the minor arc and the longer one is called the major arc. Right? As you can see in the figure above, like you were to refer the arc AB, you could mean that either one, right? Typically, one arc is what? The small part which is less than semi circumference. So that is the minor arc part, and another one is the major arc, right? And how to find out the basically length of an arc? So formula for length of an arc is what? Theta upon 360 into 2 pi r. So 2 pi r, as we know, that is the length of the entire circumference, like the basically length of the circumference. And then we'll take that portion, like, so if suppose that 90 degree we are taking 1/4, so 90 upon 360, so means we are taking 1/4 of the circumference. So as per the theta is our central angle. So as per the theta, as per the value of the angle, we are finding the length of the arc. And how to find out the basically what is the angle of the arc? So angle of the arc is what? Angle subtend to the center. That angle is known as angle of the arc. So we have angle of the minor arc as well as the angle of major arc. So what is angle of an arc? Angle measure in the angle formed by the arc at the center of the circle, that is known as angle of the arc. Then we have a radius of an arc. So what do you mean about the radius of an arc? The radius of an arc or segment is the radius of the circle of which it is a part, right? So whatever part is there. So what is the radius? Radius of an arc is what? The radius of an arc or segment is the radius of that circle of which it is a part. And we have a formula to find out the radius of an arc. So formula is what? H upon 2 plus W square upon 8H. This is the formula to find out the radius, right? So where W is what? Length of the chord defining the base of the arc, and H is what? Height measured at the midpoint of the arc base. Here you can see the one diagram where H is what the height and W is what? The length of the chord defining the base of the arc. So we have the base of the arc, that is W, and h is what the height measure at the midpoint of the arc base. So if you know this formula, so you can easily find out the radius of the arc. Now let's discuss sector. So sector of a circle is a part of area of circle between two radius. So, or we can say that the part of the circle enclosed by two radius of a circle and their intercepted arc, right? That is pi shape part is what of that pi shape part is what circle. So we can easily understand that like you example from the pizza. So one slice of a pizza is a very good example of a sector. So here in the diagram we can see the green segment shown is a sector, and OT and OW are radius, and point O is the center. So TOW is a sector of circle. And how to find out the area of sector? So similarly, we know the entire circle area is what pi r square. So we will take that part of the area. So we will take the center angle value, that is theta. So area of sector will be theta upon 360 into pi r square. Pi r square is the entire area of circle, and then we are taking that portion area. So theta upon 360. Again, I'll take the same example. 90 degree if we'll take the central angle. So 90 upon 360 means what? 1/4 of the area of circle we will take. So, but we have the universal formula. Area of sector is what? Theta upon 360 into pi r square. Segment, a region bounded by a chord, and one of the arcs connected by the chord's endpoint is a segment. Here we can see in the diagram that RS is the chord and the region bounded chord and the arc RS is a segment. The blue color part shown in the diagram is a segment of a circle. So we can say that segment is what generally a sector basically minus the triangle formed by the two radius. We can also find out that way. And what is the perimeter of the segments? We can easily find out. There is a direct formula to find out the perimeter of segment, which will be length of the arc plus length of the segment AB. Okay, so the formula is what? Direct formula is what? Theta upon 360 into 2 pi r plus 2r sine theta upon 2. So that way we can find out the perimeter of segment. And what is the area of segment? Area is equals to area of sector minus area of triangle OAB. So area will be what? Theta upon 360 into pi r square, that is the area of sector. And then we are going to minus the the top circles, which will be minus 1 by 2 pi r square sine theta. We know that, I just want to recollect the memory, that we have done one formula. If two side and one angle is given, so we know the formula of triangle is what? Half AB sine C. So that way we will use the formula, and we can basically remove that outer circle, so we can easily find out the area of segment. Sagitta. So what is sagitta in the circle? So when we have a one sector, so basically height of an arc or segment is known as sagitta. So we have like the one small sagitta, and we have the long sagitta. So what is sagitta? Sagitta is the height of an arc is sagitta. It is a perpendicular form from the midpoint of arc's chord to the arc itself, right? So how to find out the basically height of the sagittas? So finding the height of the sagittas, as we know the as it forms 90-degree angle at the chord, so we can use Pythagoras theorem to find out the height of the sagittas. But again, what are the datas are given, and as per the different, because in the examination they will give the different datas and they will check the datas. So how to find out the value of length of the sagitta? So we have the formula, direct formula. S is equals to R plus minus root of R square minus L square, where S, which is denoting, which we need to find out, that is the length of the sagitta, R is the radius of the arc, and L is the 1/2 of the distance across the base of the arc, or half the chord length. We can easily find out if they are asking us to find out S. If R and L is given, R is what? Again, I will discuss. R is the radius of the arc, and L is the half of the distance, the base of the arc, right? That is the half distance we will take it. And if we need to find out L itself, so we have a formula that L is equals to R sine A upon 2R. What is A here? A is the length of the arc. So we can find out L also. L is what? Length of basically uh, 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 L is what? 1/2 of the distance across the base of the arc. So here you are seeing the in the sagitta, where the midpoint is touching, so dash distance to the outer point circumference, that distance will be the L here in the formula. And if we want to know the radius, if we have to calculate r, and if sagitta and the chord is given, so the formula will be s square plus L square upon 2s. And lastly, that if we need to find out again L, and sagitta and the radius is given, so formula will be L is equals to root of 2sr minus s square. So these are the four formulas. So because sagitta's problems are sometime student, they feel very much difficult, they feel difficulty to solving these kind of the problems. So if we have the ready handy formulas, so that way we can solve, or we can easily derive by using the trigonometry. We can easily derive from the triangle properties, or trigonometry properties, right? It's a very simple way we can easily derive these formula our own way. We can simply apply the Pythagoras theorem, because here it is forming the base of the arc and the height of the arc, they are forming 90 degrees. So we can always apply Pythagoras theorem, and then we can derive these formula also. But I'll strongly advise you, if we have the ready handy formulas, so we can save a lot of time to get the answer. Concept 4, intersecting chord theorem. When two chords intersect each other inside a circle, the product of their segments are equal. Here you can see in the diagram where we have one chord and we have two chords, chord AB and chord CD, and we have, for chord AB we have two parts. When they are point of intersection, we have divided in, one part is A, another part we have written B. Similarly, we have written C and D for the another chord. So the theorem says that when two chords intersect each other inside a circle, the product of their segments are equal. So product of their segment will be equal. So A into B will be equals to C into D. So this is very simple theorem, that which is, if two chords, they are intersecting each other, so their products of equal segment will be equal. Concept 5, intersecting secants theorem. So when two secants lines intersect each other outside a circle, the products of their segments are equal from the outside intersecting point. So here you can see in the diagram where point P is basically a point outside from the circle, and it has two secants, like it is from point P, there are two secants are originating. So secant PAB and secant PCD. So the theorem says, the intersecting secant theorem says, that when two secants lines intersects each other outside a circles, their product of their segments are equal from the outside intersecting point. So here we can see there two segments of the line will be what? PA and PB. If we'll talk about the first secant, so there are two segments will be what? PA and PB. And another secant, so other two segments will be PC and PD. So here, as per the theorem, that we can say that they are products of each segment. So PA into PB will be equals to PC into PD. So this is like, it's very simple concept, where outside is a point, and two secants are there, and two segments are there. So segments, the multiplication of the segment will be equals to multiplication of the segments to the other secant. Concept 6, intersecting secant angle theorem. So in the figure above, the line PB is a tangent of a circle, and in the earlier diagram where we can see that the outside line, there was a two secant. So here, instead of two secants, we have one secant and one tangent. So here we have PA is equals to PB. So then we can say that product will be what? Equal, so that will be PB square. So the theorem will be PB square is equals to PC into PD. So this is the same theorem as we have earlier discussed, the two secant theorem. So where we were saying that PA into PB is equals to PC into PD. But here, since PA is equals to PB, because tangent only touches one point at the circle, so definitely, so we can take PA is equals to PB, so we can take it PB square, either PB square or PA square is equals to PC into PD. Concept 7, alternate segment theorem. So what is the alternate segment theorem? The alternate segment theorem, basically also referred as this, the another name of alternate segment theorem is what? Tangent chord theorem. So what does this theorem says? That angle measured between a chord of a circle and the tangent through any of the chord's endpoint is equals to measure of an angle in the alternate segment. So here you can see in the diagram that we have the tangent is BD, and we have the chords CB and AB. So the angle which is we are forming between the angle measure between the chord of a circle and the tangent through of the chord's endpoint. So the angle CBD, here that theta will be equals to the basically equals to the measure of an angle in the alternate segment. So alternate segment will be what? Angle A, which we are showing angle alpha here. So we can say that alternate angle theorem says that angle CBD, here like tangent and the chord, angle between this tangent and the chord CBD will be equals to the angle uh, in the alternate segment. So alternate segment will be what? It will be equal to angle CAB. So now we can say angle alpha is equals to angle theta. So and we can also say that angle alpha and angle theta are alternate angles. So again that what is the alternate segment theorem says? That alternate angle theorem says the angle measured between a chord of a circle and a tangent through any of the chord's endpoint is equals to measure of an angle in the alternate segment. So here we can say the chord CB and the tangent BD, they are forming an angle, and that angle will be equals to the angle opposite to the opposite basic angle which is there in the alternate segment. So angle alpha is equal to angle theta here in this diagram we can say. So this theorem is also known as we have discussed, tangent chord theorem. Concept 8, angles and angle theorems in a circle. So in this concept we are going to discuss the basic concept about what is inscribed angle, what is central angle, and what is the central angle theorem. So in the layman, like we should know that, because so many times in the examination it comes inscribed circle or inscribed angle. So we should know exactly, like it has to be a very much clear picture in your mind what is the inscribed angle. So you can see in the diagram that in the circle where we have point P, there is an angle which is formed by the arc AB. So that angle is known as inscribed angle. So what is the inscribed angle? Basically the angle subtended at a point on the circle by the two given points on the circle. So that basically angle is known as inscribed angle. So so inscribed angle is what? The basically it's an angle subtended at a point on the circle. That angle is known as inscribed angle. And so how to find out the uh, what is the value of the inscribed angle? So formula is what? Basically 90L upon pi r. That is the angle in degree we can find out. L is what? Length of the minor arc or shortest arc, like that we can say AB, and r is the radius of the circle. So if we know this formula, then we can find out the angles in, like the degree, right? So 90L upon pi r of the, that will be the formula for inscribed angle. Then next we have central angle. Central angle, the angle subtended at the center of the circle by two given points on the circle. So simply, like in two points are there, and that angle is subtended from that point. Whatever angle is subtended to the central, that angle is known as central angle. Or we can say that that is also, like the 2 points, they are forming an arc, and that angle of that arc is the central angle. So central angle is what? The angle subtended by the sector of the center of the circle. That angle is known as central angle. Now we have theorem, central angle theorem for major arc, and center angle theorem for the minor arc. So what is the major arc theorem? Major arc theorem says that central angle subtended by 2 points on a circle is twice the inscribed angle subtended by by those points. So here we can see in the diagram that we have 2 points AB, and so the other part is the part where point P is here. So that is the major arc. So angle, the central angle AOM, the angle formed by the point AB and O, is what AOB, angle AOB will be whatever value it will come. Let's say the value here is given 2m, and if we'll take the value of APB, that will come half. So we can always say that central angle subtended by 2 points on the circle is twice the inscribed angle subtended by 2 points. So angle APB is the inscribed angle and angle AOB is a central angle. So central angle, the value of inscribed angle is always half of the central angle, but this is in case of only and only for major arc. And for the case of minor arc, we have a direct formula that we can easily find out. The angle is equals to 180 minus half of the central angle. So that way we can find out the angle of the arc here, angle of the minor arc here, right? So this theorem holds basically when we have uh, the arc is what, minor arc, right? So the two angles have a different relationship, like the for the minor arc is different and the major arc is different. So whenever we are finding the angle in the minor arc, so we will use the formula 180 minus central angle upon half. And if we are finding for the major arc, then we will take it, we have a simple relation that central angle is double of the inscribed angle. Concept 9, two angles in the same segment. A small concept, when we have two angles in the same segment. Here you can see in the diagram where we have two angles in this one segment. So let's say one segment, the red line which is one segment, and then we are forming any two angles in the at any point on the circle. So the value of these two angles will be same. So we can say that any two angles in the same segments are equal. Concept 10, equal chord. So if two equal chords are there in the circle, so they have some unique properties. So first property is what, they have three unique properties, we can say. The first property is what, if two chords of circles are equal, then the center of the circles lies on the perpendicular bisector of the two chords. So if two chords are there, here you can see in the diagram, let's say two chords A and B, AB and AC are there. So if we'll take their perpendicular bisector, right, from where these two chords are meeting, and if we'll take the perpendicular bisector of these two chords, so definitely the center of the circle will lies on perpendicular bisector. So here property number 1 of equal two chords is very important. If two chords of circles are equal, then the center of the circle lies on the perpendicular bisector of two chords. So again, it is very important that two chords are equal, then the center always lies at the perpendicular bisector of these two chords. Second important property is what, equal chords of a circles are equidistant from the center. So if two chords are equal, they are always equidistant from the center. And third is what, if equal chords always basically subtend equal central angle. So if two chords are equal, so they always are going to subtend a equal central angle. So these three unique properties are there for equal chords. Concept 11, perpendicular from the center of a circle to a chord. Here as you can see in the diagram that AB is a chord and O is the center, and if you are drawing a perpendicular from center to the chord, and perpendicular we are drawing at point X, so we can always say that the perpendicular from the center of the circle of the chord bisect the chord. So when we are drawing a perpendicular, so it is going to bisect, meaning it is going to divide the chord AB in the two parts, or we can say AX will be equals to XB. So we can say that perpendicular from the center of the circle to the chord bisect the chord, and here we can see the diagram OX is the perpendicular on the chord AB, and this point X divides the chords AB in two equal parts, or we can say AX is equals to BX, and opposite of this, the converse of this is also equal, right? So we can say the perpendicular bisector of two chords of circles intersects at circle. Concept 12, two circles intersect properties. So So if two circles intersects in 2 points, then the line through the center is the perpendicular bisector of the common chord. So here we can see that two circles, they are intersecting point A and B. So and if we'll take a the line which is the perpendicular bisector of the common chord. So common chord is what, AB here, and if we'll draw the line uh, from center of the circles on the chord, so it is going to divide the chord in the two equal parts. So we can say that if the two circles intersects in 2 points, then the line through the centers is the line through the centers is the perpendicular bisector of the common chord. So if two circles intersect at 2 points, then their centers lie on the perpendicular bisector of the common chord. Here we can see AM will be equals to BM, and angle AMQ, here you can see angle AMQ will also be equals to angle BMQ, and the angle will be 90 degree. So this is again important concept. When two circles, they are intersecting each other, so their chord and the perpendicular bisector from the center will be always, the chord will be, the two parts of the chord will be equal. So AM will be equals to BM. Next is what, congruency of the circle. If two circles can be congruent if and if only they have equal radii. So if they have equal radius, then only they will be considered as the congruency. So congruency of the circle is what, two circles can be congruent if and only if they have the equal radius. There is one more concept for the two circle. The concept 3 is what, that two basically concentric circles and the chord of the larger circle. So two circles, they are concentric, like their center is the same point. So let's say here you can see in the diagram where we have two circles, inner circle and the outer circle, and they have a common center O. So what is the theorem says that in the two concentric circle, the chord of the larger circle, that is the tangent of the smaller circle, is bisected at the point of contact. So you can see that there is a tangent APB on smaller circle. So this point P will that point P, so if you are taking a this point P basically will divide the tangent or chord of the outer circle in the two equal parts. So AP will be equals to AB. So always we can say that two concentric circles and the chord of the larger circle. So in the concentric circle, the chord of the larger circle, that is the tangent to the smaller circle, is bisected at the point of contact. Now in two circles, we have one more concept, that is that two circles touches internally and the distance between the center of the two circles. So here you can see in the diagram, when two circles are there and they are touching internally. So what will happen, like if you want to know what is the distance between their centers, so their distance is always equals to difference of their radius. So we can say distance between C1 and C2 will always be equals to R1 minus R2. Concept 13, direct common and transverse common tangent. So what is direct common tangent? So if the common tangent cuts the line joining the centers, but not between the two circles, but on the one side of one circle, such common tangent is called the direct common tangent. And how to find out the length of the direct common tangent? We have a direct formula, root of distance between their center square minus difference of their radius, R1 minus R2 square. So we have a direct formula to get the length of the direct common tangent. Then we have a transverse common tangent. So what is transverse common tangent? A common tangent that cuts the line joining the centers in between the two circles is called the transverse common tangent. And length of the transverse common tangent in two circles will be what? Root of distance between their center square minus sum of their radius square. So R1 plus R2 is square. So this is the formula for length of transverse common tangent in two circles. Concept 14, some important facts for circles. So first very important fact about the circle is what? That maximum or minimum number of common tangent in one circle are 0 to 4. We can form maximum 4 common tangents, and minimum we can form 0 common tangent. Next small important fact is what? The point of contact of a circle. So point of a contact of a circle is common tangent can be drawn touching both the circles at the same point. So that will be that was known as point of contact of circle. So what is the in the question sometimes they will give this definition, that what is the point of contact. So point of contact of circle is common tangent can be drawn touching both the circles at the same point. Next is what? Three, again interesting fact is what? Three or more non-collinear points and circle. So there can be one and only one circle passing through three or more non-collinear points. So we cannot make more than one circle if three or more non-collinear points. Concept 15, concyclic points. We say like a line segment joining two points subtends equal angles at the two other points lying on the same side of the line. So in that case we can say that the 4 points are concyclic points. So here you can see in the diagram, like there are the line AD is there, or point AD is there, and they are forming a central angle, and also point B and C are there, they are also forming the central angle. So if their central angle are equal, so in that case all 4 points are known as concyclic points. Concept 16, cyclic quadrilateral. Like a quadrilateral is called cyclic quadrilateral if all the 4 vertices lie on a circle. So when all the 4 points, 4 vertices are on circle, that quadrilateral is known as cyclic quadrilateral. And in a circle of all 4 points ABCD lie on the circle, then quadrilateral ABCD is a cyclic quadrilateral. But very important property of cyclic quadrilateral is what? That sum of pair of opposite angle of a quadrilateral is always 180 degrees. So, and if you take any opposite angle in cyclic quadrilateral, if sum will always come 180 degree. So that is the one very important property of cyclic quadrilateral. Concept number 17, quadrilateral outside the circle. So when we draw a quadrilateral outside the circle, so it has two very important properties. First is what? The quadrilateral outside the circle, if a circle touches all the 4 sides of quadrilateral, then sum of the two opposite side is equals to sum of other two. So here you can see in the quadrilateral A, B, C, D. So the length of AB will be, and length of AB plus length of DC will be equals to length of BC plus length of AD. Also there is one more unique property, that tangent segment property. Here you can see that line AD, tangent AD is touching point H at the circumference of circle. Here also tangent AB is touching at point E, and BC is touching F, and DC is touching at G. Also the tangent segment will be equal. So we can say always AH will be always equals to AE, and BH will always equals to DG, or CG will always equals to CF, and BF will always equals to BE. So these are the two unique properties of quadrilateral outside the circle. Concept 18, intersecting secant angles theorem. So what is basically intersecting secant angles theorem? The angle made by two secants intersecting outside a circle is half the difference between the intercepted arc measure. So here you can see in the diagram, point P is outside, and we have two secants PAC and PBD, and they are forming two angles, like one is two angles, one is from arc AB and another is from arc CD. So what is the theorem says, that if we'll take the difference between these two central angle, so that will be the half of the angle P. So here we can say angle P will be angle COD minus angle AOB divided by 2. So in this video we have covered all must know basic and advanced concepts, formulas and theorems related to circle, and I'm sure this video will definitely very much helpful to you, and you will able to understand each and every concept. You will able to revise all the concepts quickly in one go. So guys, thank you for watching this video.